All right, hey everyone. My name is Simon Tran, and I'm back going over these reviews. And today we're gonna go over derivatives, extrema, and applications. So I have a list of questions, and I'm gonna do the even questions, and I'm hoping you guys will do the odd. So we have question number 2. We have if f of x is equal to sine of x over 2, then there exists a number c in the interval pi over 2 between pi over 2 and 3 pi over 2 that satisfy the conclusion of the mean value theorem, and which of the following could be c. So the mean value theorem, pretty much the definition of the mean value theorem is that suppose f is continuous on interval from a to b and differentiable on a to b, then there exists some argument c such that c is in between a and b, right? And then we can write an equation for that. You can write as f prime of c is equal to f of b minus f of a over b minus a. So we can plug in. So let me just find this part first. So we can write it as f of, and our b is going to be 3 pi over 2 minus f of, and then our a is pi over 2 over 3 pi over 2 minus pi over 2. And then on the left side, we just need to find the derivative of that function. So the derivative of sine of x over 2 is cosine of x over 2. And then chain rule, remember that part? We need to find the derivative of the inside. So it's going to be 1/2. So we're going to divide cosine of x over 2 by 2. So now we need to find what the right side is. So we plug in 3 pi over 2 into our first function, the sine of x over 2. We would get sine of sine of 3 pi over 4 minus sine of, and then we plug in pi over 2 into that function. We would get pi over 4. And then divide that by 3 pi over 2 minus pi over 2. And then that will give us, and let me put this down. And then I'll just bring this down. And then that will give us, let's see, sine of 3 pi over 4 is square root of 2 over 2 minus, and then sine of pi over 4 is also square root of 2 over 2 all over 3 pi over 2 minus pi over 2, and that is just simply 0. So let me move over here. So writing the left-sided cosine of x over 2 all over 2 is equal to 0. So now we need to find what x is, or I guess c in this case. Actually, I should probably change that. C. So we're going to multiply 2 both sides. We will get cosine of c over 2 is equal to 0. So now we need to know what c is. So pretend c is our x. Cosine of x over 2. So let's see, what would our x be? Maybe pi? Of course, you can maybe take the inverse, I guess, to find what c is, but let's go with pi. Cosine of pi over 2, let's see, pi over 2 is 90. Cosine of 90 degrees is 0, so yes, that works. So it looks like our answer is D. So C is equal to pi. So you can just think about it, or you can maybe just take the, I guess, inverse of that function. So like you can do it as C over 2 actually. So pretending you didn't know what C is, right? You can just do this, find the inverse, and then multiply 2 to both sides, so you get C is equal to 2 times cosine, or the inverse of cosine, 0, and you can plug that in your calculator to find what your C is, and C will be pi. Alright, number 4. Given the function defined by f of x is equal to 3x to the power of 5 minus 20x to the power of 3, find all values of x where which the graph of f is concave up. So for this problem, we need to find the derivative of that function, but we have to do it twice. So we need to find the second derivative of that function in order to find our concavity. So let's find the first derivative of that function. So we have f of x is equal to 3x to the power of 5 minus 20x cubed. So now we need to find the first derivative of that function. So f prime of x. We're going to bring the 5 down, so it's going to be 15x to the power of 4 minus, and then bring the 3 down, 60x to the power of 2. And now we need to find the second derivative. So we have f double prime of x is equal to, bring the 4 down, we have 60x cubed minus 120x. So now we need to set the second derivative equal to 0. So we need to set 60x cubed minus 120x equal to 0, right? Because if we want to know where it's concave up or down, we need to set this the second derivative equal to 0, and we need to find our I guess our x values where it's equal to 0. So I'm gonna factor out 60x. So we're left with x squared minus 2. So we have x is equal to 0, and x is equal to plus or minus square root of 2. So we're going to use these x values to make a line chart. And then I'm going to put 0 in the middle, and then negative square root of 2, and then positive square root of 2. And up here I'm going to have f double prime, and then our regular f function, original function. And I'm going to see where it's positive and negative. So let's see, if I plug in negative 2 in, you can use your calculator for this. So if I plug in negative 2 into our this function, I would get a negative number. So let me use a different color. So I would get a negative number, meaning that in our original function it will be concave down. Now if I plug in a number in between negative square root of 2 and 0, let's say negative 1, I would get a positive number. And if I plug in a number in between 0 and square root of 2, like positive 1, I would get a negative number. So it'll be concave down. And then a number greater than square root of 2 would be a positive number. So it'll be concave up. So now if we read the question again, it says it's looking for concave up. We need to find where. Find all the values of x for which the graph of f is concave up. So our answer would be D. X values are greater than square root of 2 and in between negative square root of 2 and 0. All right, number 6, we have the radius of a sphere is increasing at a constant rate of 2 centimeters per second at the instant when the volume of the sphere is increasing at 32 pi centimeter cube per second. The surface area of the sphere is what? So this is a related rate problem. The steps to solving a related rate problem is we need to list or write down. You need to first write down what we know. And then second, write what you're solving for. And lastly, what equation will you use to solve for that, whatever you're looking for. So what do we know? We know that the radius of a sphere is increasing at a constant rate of 2 centimeters per second. So we can write that as dr over dt is equal to 2 centimeters per second, right? Because it's increasing at a rate, constant rate. So it will be dr over dt, or r prime. And let's see, what else do we know? We know that the volume of the sphere is increasing at 32 pi centimeters cubed per second. So we can write it as dv over dt is equal to 32 pi centimeters cubed per second. And we are solving for the surface area, SA. And then what equation will we use? So we know that we're given the volume of a sphere. So all we have to do is write the equation of that volume. So the equation for the volume of a sphere is V is equal to 4 pi r cubed all over 3. So now we need to take the derivative of that function, or that volume. So we would get dv over dt is equal to, so it would be 4 pi r squared times dr dt. So we're given what dv over dt is. It's 32 pi. So write it as 32 pi is equal to 4 pi r squared times the derivative of, the dr over dt, which is 2. What we know about 4 pi r squared, that's the formula for the surface area of a sphere. This is the surface area of a sphere. That's the formula. So we're going to divide both sides by 2, right? Because we're looking for the surface area. So I'm going to do that. I have 32 pi equal to 4 pi r squared times 2. I'm going to divide both sides by 2. I will get 16 pi is equal to 4 pi r squared. Since this is the surface area, that will be equal to 16 pi. And then that will be our answer, C. All right, number 8, we have the velocity of a particle at time t is given by the function v of t, or the velocity in terms of t, is equal to t cubed minus sine of t plus 2. What is the acceleration of the particle at time t is equal to 2 pi. So we are given the velocity. In terms of t, so t cubed minus sine of t plus 2. So we want to know what the acceleration of the particle is at time t equal to 2 pi. So we need to find the derivative of that function, velocity, which will give us the acceleration. So we have v prime of t, or a of t, is equal to 3t squared minus cosine of t, right? So now we need to find what the acceleration of the particle at time t is equal to 2 pi. So all we have to do is plug in 2 pi in. So we have a of 2 pi is equal to 3 times 2 pi squared minus cosine of 2 pi. And that will give us, let's see, 2 pi is 4 pi squared. So times 3 is 12 pi squared minus cosine of 2 pi is 1. And that's our answer, A. Number 10, we have the maximum acceleration attained on the interval from 0 to 3 by the particle whose velocity is given by v of t is equal to t cubed minus 3t squared plus 12t plus 4. So we want to know what the maximum acceleration is. So if we find the derivative of v of t, we will get the acceleration is equal to 3t squared minus 6t plus 12. So now we want to know what the maximum acceleration is, so we can just try to find what the acceleration is at t is equal to 0, t is equal to 1, and then equal to 2, and then 3, because we're given the interval from 0 to 3. So if I try a of 0, right, that will give me 12. Put 0 into this function, you will get 12. If I try a of 1, I will get 9. And then a of 2, I will get 12 again. And then lastly, a of 3, I would get 21. And it looks like 21 is the highest number, right? So it's the maximum acceleration. It's bigger than a of 0, a of 1, and a of 2. So D is our answer.